Hello everyone. In the previous lecture, we looked into the three cloud computing models, namely infrastructure as a service, platform as a service, and software as a service. In that context, there was a discussion around how much of the cloud architecture is visible to the users depending on which service they are accessing. We noted that in software as a service, the users merely access the software and applications made available on the cloud. In platform as a service, a developer can use the various development platforms on the cloud to develop their own applications. In infrastructure as a service, they can do everything offered by platform as a service, plus they are also able to control some elements of the backend as well. So this could mean they could also configure some of the resources which are behind the scenes. We gave some examples of each of the models, and towards the end of that lecture, we also discussed cloud economics, which looked into the motivation um, as to why businesses have to adopt cloud computing. We also discussed utilization of resources, and we discussed underutilization and overutilization and the impact it has on the cost of deployment. In this lecture, we will look at service-oriented architectures, or SOA, and we also look into web services and how they work. Developing software or applications that are based on the cloud requires a different means of putting the software components together, and this is significantly different. It's significantly different than traditional approaches to software engineering. Well, as you know, the paradigms for cloud computing development have significantly evolved over the last few years, and new architectures are being used for cloud-based app development. And this is what we mean by service-oriented architectures, because that's a new architecture which is used to develop applications on the cloud. And we also then have the web services, which in simple terms means you are accessing service components over the web. So this could mean something like you access a cloud provider to see what software components they are providing, and then you access some of those components over the web. So they try to make it very simple in terms of accessing the components and using the components into your own applications. In this lecture, we will look into how these architectures are organized and the communication mechanisms and protocols used for service-oriented architectures and web services. In terms of software development, this lecture will give you an appreciation of the methods used by developers to detach themselves. So it's about detaching yourself from monolithic approaches. So I think last week I mentioned about the monolithic approach to software engineering, where you just write one large chunk of code. Obviously, we have to detach ourselves from that, because the application development for cloud computing doesn't work like that. So yes, so we have to get away from monolithic development, and service-oriented architectures and web services will allow you to adopt approaches which lead to serverless development, really. So we'll look at these two in this lecture. So the agenda for this lecture will be covering service-oriented architectures and web services. We will look into the SOA model, and we will define what web services are. We'll also look into some of the technologies used to enable the communication between the developer and the components made available by the service provider. So guys, this is where I once again remind you that you will benefit from having a prior software engineering background. We are not going to be explaining basic terms because we expect that you have suitable background in software engineering. Also, I would like to say that it might be worth thinking about. It might be worth thinking about how all of this applies to your assessment. During this discussion, we will cover a lot of key terms like the ones you see out there, things like contract based, loose coupling, abstraction, reusability, autonomy, discoverability, etc. etc. So hopefully by the end of this lecture you will be able to fully appreciate how service-oriented architectures and web services make it very easy to manage the software development process, and also also to cut a lot of development time. Right then, so we have looked at distributed computing. We discussed that a couple of lectures ago, and I might have briefly mentioned there that distributed computing supports distributed applications, which mean that several components could be located across multiple machines and they interact with each other. Um, there are various ways this can be achieved, and the term client server comes to mind immediately, right? Obviously, in a client server model, a client and a server talk to each other in you're rather using what we call as a persistent socket or a web socket. Now the question is, what is a persistent socket? What is a persistent socket? A persistent socket is, in simple terms, means it's a connection between a port on the client and a server, and this connection is maintained permanently. It's maintained permanently till one of the parties decide that the connection is no longer required, right? So it's pretty much like a permanent connection till one of the parties say, that's enough, I don't need your connection anymore, I don't need this connection anymore. So that's when the connection gets torn down. So that's what a persistent connection means. Next on the list is a distributed objects model. These are distributed client and server objects. These are coordinated by solutions, such as, there are quite a few actually. So some of the common ones are, of course, you might be aware of DCOM, or Distributed Component Object Model, which is Microsoft's view on how distributed computing should be managed. DCOM allows an application to start a server. It allows for an application to start a server on another machine in order to invoke their functions. There is also the CORBA, the CORBA, which is similar to DCOM. CORBA is Common Object Request Broker Architecture. So both of these help different programs distributed across networks to communicate with each other. There's also the Java RMI, Remote Method Invocation. All these solutions are pretty much do the same in that they enable communication between different distributed programs. Also, one thing which is common among all these is that they are all on the decline. So the usage of these technologies are on the decline because they are not fit for purpose for modern cloud-based applications. So that brings us to web services and RESTful API, RESTful web services. This is about highly efficient provisioning for interoperability. So highly efficient provisioning for interoperability. It is based on XML. In simple terms, a web service is a resource that is made available. I mean, think about it, that's what it is. I mean, it's a web service. It's a service which is made available on the internet, and these services can be invoked over the internet by applications or developers, and they use SOAP, which is a protocol. We'll discuss more about SOAP a bit later on. So that's SOAP, which is a protocol for messaging between applications and the service. RESTful web services define constraints that bring about properties and behavior with regard to performance, scalability, and the services. RESTful stands for representational state transfer. The resources provided by RESTful web services are accessed via the web, and I think I've mentioned this before. So yeah, everything you do. So with regards to cloud computing development, with regards to applications for the cloud, a developer can remotely invoke some of the services provided by cloud service providers via the web. And also the good thing about all this is typically they use standardized protocols like HTTP or Hypertext Transfer Protocol, and it's used as a stateless communication protocol. In this architecture, the client and servers exchange information about the resources using standardized interface and communication protocols. And similarly, you have JSON or JavaScript object notation, which can be used to exchange information about the methods and attributes within a service. Again, like all these things, HTTP can be used as a simple ways or a simple protocol to enable the communication between clients and JSON web servers. Right then, so excuse me. So let's look at what happens in the real world. Well, in the real world, a service is something being offered or performed by a service provider. It takes some input. Yeah, so you provide some input. You discuss what you need. That's the input. For example, the requirements and how the end product should look like. Based on this, the service provider produces some desired results. So no matter which service it is, it has certain characteristics, certain attributes. Or this could also mean how a service must be invoked. For example, you may have to negotiate the price, the execution, the time, and the constraint. This could be the input. And based on the input, the services will shape the outcome of the service they provide. The components there. So the components, we use the word component and service interchangeably, so don't get confused. So we will say the components will shape the outcome of the service depending on what input you provide. Now, when you contextualize this to a service in the real world, in the software world, it's what we do in real life. So we need some input. We need to tell how the input must be processed, and then we get the output. So the common thing about all services is that there is a request and response model. Don't forget that. There is always a request and response model. In a nutshell, what that means is a client requests and a server responds. Simple as that. And we are used to how we are already aware of how this works. I mean, the reason we are discussing all of this is because you will see how all of this is facilitated using web services and service-oriented architectures, right? So when we discuss a lot more deeper into these, you will see how that request and response model works. The principle of request and response in software engineering has been there for, as you guys know, it's been there for a lot of years. In terms of client-server programming. But what we are doing now is adapting the same model. We are adapting that to cloud environments. And web services and service-oriented architectures allow us to fully tap into the potential of cloud providers. The interesting thing about all this is a cloud provider might have created a set of lightweight components that are specific to their services. I'll explain this a bit more later on. So what you can do is these days, if you want to develop a software for a cloud provider, you can see what services, what pre-functions they already offer, and you can sign a contract, and then you can use their components. You can use their components to develop your applications without actually knowing what's happening behind the scenes. So yes, so it makes software engineering very, I suppose, manageable, and it takes us away from the monolithic approach, as I told you before, from the monolithic approach of developing software. So let's look at SOA, which is service-oriented architecture. Service-oriented architecture. It's an architectural concept for developing software systems. It's about using reusable building blocks called services. The very interesting thing about this is that a cloud provider might have a set of lightweight components which are specific to the services. I've mentioned this before. So a cloud provider might give you a range, a huge collection of services, right, which might be specific to that cloud platform. Okay. So in this architecture, you would often find proprietary protocols. Now, here's a very interesting thing. So sometimes you will find proprietary, not protocols, I beg your pardon, proprietary components. So you would often find proprietary components that are made available to the users. When I say proprietary, it means that it may not be open source. So it all depends on what kind of components they are. So a platform, say maybe Financial Force or Azure or whatever, they might create specific components which are, a well-guarded secret. Having said that, you can still use it to get some services from the cloud platform, right? So you subscribe to those components. Yeah, so what a developer would need to do is they would need to check with the cloud provider if they have got any component that they can make use of, and they can they can use a set of parameters, like you normally use a function, a set of parameters, and then using those set of parameters, the services will return a suitable output. The cloud provider, we must remember this, the cloud provider might decide not to expose the internal working of the component. And by the way, why would anyone need to see the internal working of a component? So what we are saying is a cloud provider is providing some components to be readily used by a developer. So it takes the stress from the developer. The developer doesn't have to think about what happens behind the scenes or how these components are working. That's not his business at all. Right. So this is why we say that these are reusable components, because all users can use the same services or components over and over again without actually having to develop them. So you don't have to develop them. So as you can see, this will avoid creation of monolithic software because it cuts down many lines of code, and each task could be offloaded to a particular service. The user, once again, please remember, the user does not develop the service, but he merely uses it. The user does not develop the service, but he merely uses it. Services in SOA, service-oriented architectures, are autonomous, meaning they can work by themselves, and they are stateless business functions. They are stateless business functions. They accept requests and return responses. And all of this is based on well-defined standard interface and standard protocols. But beneath all this, there is a very complex architecture, which normally, if you are a developer, you won't concern yourself with the complexities. So here is how the various parts of SOA hierarchy is organized. There is, of course, the application front end, which is the developer's end. So a US developer will use the front end. The application front end could use a set of services which is enabled by the cloud provider. there is the service repository, which is essentially a database. Is essentially a database that contains the software and metadata. In other words, it's a registry. The service repository is a registry or a catalog. Guys will definitely discuss this a bit later on. So what we are just saying is the service repository holds some information about the kind of services available. In a nutshell, in very plain English, that's what it means, right? It's a registry or a catalog, right, which holds key information on the various services that could be made available to the user. So you might ask, what's the use of the service repository? Why do we need a service repository? That's because when a developer wants to use a particular service, the first place they will look for the service or the information about the service will be within the service repository, right? So it's like a telephone directory. Just for a simple example. So yeah, you want to look for what services are being offered. So you look at the yellow pages or whatever, right? Get some information. So before you start the development process, the service repository is consulted, I suppose, is queried to see what services are being offered, and the services are picked based on that information. So the purpose of the service repository is to help discover components, and it also allows for businesses to businesses to communicate with each other using web services, right? So the repository, if you ask me what is in a repository, it holds the policies, the process, and the attributes related to SOA, say maybe related to SOA governance even. So it contains various bits of information about different services. So along that line, you also see the service bus. It's a set of rules on how to integrate different applications and how to communicate between these applications. The good thing about this is when applications communicate over the service bus, they do not need to know the implementation knowledge of other applications, right? So when multiple applications talk to each other over the service bus, they don't have to concern themselves, they don't have to be bothered about what kind of an application they're talking to, right? So it gives that level of flexibility. So in that context, we use the word decoupling. So we use the word decoupling to describe this independence, right? So the word decoupling is used to describe this independence of each application that are communicating over the bus. Now, previously, if you were to develop a system which requires integrating different applications, you would have to create some sort of a point-to-point integration code, which is very cumbersome. And I think with the traditional approaches to inter-application communications is by embedding specific code within each application. Now that becomes very cumbersome to maintain. It also becomes difficult to scale the application, and it's difficult to manage, right? So using the service bus within the SOA architecture helps you move away from that traditional approach, right? You don't have to create a point-to-point integration, but you rather adopt a more centralized system to establish coordination among various applications. I hope it's clear, chaps. So the best way to understand this is to compare how you would do software development in SOA and go back a few years and go to traditional distributed applications or client-server applications and see how different applications talk to each other, what you would need to do, right? So if you're able to compare that, I think you've got the solution to this, right? So within SOA architecture, all coordination of communication between various applications is done via the service bus. Various components is done via the service bus, but that wasn't available many years ago, right? So the traditional approaches were more cumbersome to manage. It used to be monolithic. There used to be more lines of code to coordinate the communication. But these days, using SOA architecture, that task is not that bad. Then you can see the box about contract. So the contract, in simple terms, establishes the rules between the two parties. One party provides a service, obviously, and the other consumes it. So a cloud provider provides various components to be used, but remember, there are rules to be followed. The usage of these components is on condition, or rather, to an agreement which defines the conditions of use. In simple terms, this means that the service provider and the service user should not use the components that could harm each other's businesses. So it creates a loosely coupled relationship between the two parties, right? So the contract will define the legal aspects, and not just that, it also defines the technical aspects and how to comply with them, right? So the contract is a very important it's I wouldn't use the word formalities. It's a very important phase in SOA. So the contract also tells about how much flexibility each party has within the remit of the contract. Any contract will also define the functional requirements. In other words, it tells what the components or the services will do and what they produce. It means what input a service will need and what output it will produce, right? So it's very clear cut there, and there is no ambiguities. So when you look at the documentation, when you look at the contract, it'll tell you this is the service these are services we provide. This service does this. It takes this input. It produces this output. So it's all very clearly laid out, right? So you can use it based on based on this information being provided to you. But also remember that the contract will also define non-functional requirements as well, which describe the responsibility of both parties in terms of things like say quality of service. The implementation allows for the developer to use the business logic and data to be implemented. Obviously with the implementation phase, you will need to look into what kind of data you need to process and how you will provide that as an input to the service, and what kind of an output you expect from the service. So so the implementation phase is this. So it's building the business logic using the services, right? So the implementation will benefit from the interface or the web service interface, which users which use common communication standards that can be rapidly deployed across applications. So we will look into what these common communication standards are a bit later on, right? But yes, so it's all the thing about this is be it SOA or web services, that everything is made simple for you in the sense that everything is done via the web. Using URLs and using lightweight components. So there's a lot of flexibility and in developing applications. Yeah. Right. So I just want you guys to study that. I suppose flowchart. This slide describes the flowchart of the conceptual model of service-oriented architectures. Now, if you follow the steps carefully, you will know exactly what needs to be done or what needs to happen in order for a component to deliver its service. I will walk you through the steps. The first step is with the service provider, obviously, because they have to develop a service or a component and create the appropriate document which would be accessible to a service user. The second step is to publish this information into a service catalog. So we mentioned about service catalog a bit earlier. So it's this directory service, I suppose. So the service catalog is referred during service discovery. Remember, I said in the last slide that all services are documented in the repository. In other words, when a service consumer wants to use a component, they will look for that in the repository. So that is step 3, where the service consumer will find services offered by providers so they can readily use the service in their application. Once a service consumer looks for a particular service, a list of service providers is returned to the service consumer in step 4. Now that the service consumer has got the list of services, they can use them to develop their applications and bind the service. Once the service is bound to an application, it is requested in step 6 from the service provider. In the traditional sense, this would mean that you are actually invoking the service. Assuming that the contract is followed, the service provider then delivers the service in step 7. Let us now look at the characteristics of SOA services. The first bullet point there mentions about being autonomous. I think we have touched upon autonomous briefly before. So what this means is that the service operates independently without the need to know about the existence of other services and also without the dependence on other services. Each service is a standalone component that could be selectively used by the developer from a pool of other components. The next bullet point talks about the stateless attribute of each service. So it talks about the stateless attribute of each service. The services do not remember. So please be aware that the services, each of these services, do not remember the state between requests. So it doesn't hold states. It doesn't remember the states. Because these are lightweight components, they do not have the capacity to remember the state, and also it's not required. But in those exceptional cases where a state has to be remembered, it can be done using a database which is referenced by a state ID. Because the services are lightweight, once again, it makes sense not to maintain the states, and it also makes it very easy to scale. The final point is that it follows the request response model. It's actually a variation of the client-server model where the client asks the server and returns an answer. But it's important to note that the server never sends the request to the client. So in this SOA model, the server never sends the request to the client. It is also important for you guys to remember that when we say server within quotes, when we use the word server in terms of SOA, what we actually mean is a service or a component, right? Not a physical, doesn't necessarily have to be a physical server. So please do remember that. So we now look into the web services. We look at the definition of web services, technologies, and workflow. So yeah, we now move on to explaining what web services are. And here are some definitions of web services. It's a service which is discoverable. It's a discoverable resource that executes repeatable task and is described by an externalized service specification. Okay, so what does this mean? What does all this mean? So we were talking about externalized service specification. So it means that any service can be discovered by an application. That's what provides the externalities, if that's a word, right? So it means that any service can be discovered by an application over the web and it can be invoked to perform a repeatable task. Right, so it can be invoked to perform a repeatable task. It has the externalized service specification, which says what the service does and how it must be used. The second bullet point pretty much repeats what we said before. So yeah, it's a web service which can be accessed using a URL. In other words, it can be accessed over the internet. Obviously, because it's a URL, it can be accessed over the internet. So yeah, I think yeah, I'll just quickly go through this. So a web service is a software application. It's a software application which is defined by a URI. What's a URI? It is Uniform Resource Identifier. The services can be discovered, described, and implemented using XML artifacts. So XML, you know what XML is. In the coming slides, we will see how this is done. By the way, yeah, probably going to a bit more detail on how XML plays a part in this. And yeah, all interactions with other software is again done using XML-based messaging via internet-based protocols. So that's what the slides kind of summarizes. It gives you the properties of web services, or the definition of web services. So instead of me reading off the slide, I think, well, I will read off the slide anyway, but now the thing I wanted to say is please note the keywords there, the words highlighted in bold. Look for the words, things like, self-contained, which means they're independent and they have everything within them to provide the service. And also, they are remotely executed. Also, look at the words like, self-describing, modular, etc., etc. So I would like you to make some notes on what these things mean. All right. But in terms of a web service itself, it's based on XML, as I told you before. Because they use XML, they are capable of describing their operations. That's what we mean by self-describing. So because they use XML, they're capable of describing the operations to the users. The client software is immediately able to know what a service does and what data it accepts and what it produces. All right. So again, let me just read through this definition. So web services are are a new breed of web application. They are self-contained, self-describing, modular applications that can be published, located, and invoked across the web. Right. So web services perform functions which can be anything from simple requests to complicated business process. It doesn't matter. It can be as simple or as complicated as needed. Once a web service is deployed, other applications and other web services can discover and invoke the deployed service. So I hope that's clear, chaps. Right? If it's not clear, send us some questions, and obviously we will. We've got the online sessions as well, so please feel free to ask us questions about the lecture itself. So I know I do appreciate it can sound very confusing, but trust me, guys, it's a very simplistic approach to software engineering over the for the cloud. All right, and web services are quite it's an upcoming area, so it's a very useful skill to have. In terms of software engineering skills, right? Right then. So just to reiterate, and no matter how many times we repeat it, I mean it's going to it's useful to repeat it a few times so that it kind of gets ingrained. In our brain, So let's see what a web service once again is. It's a software service that communicates over standard web protocols. So what do we mean by software service? It means components being provided by the cloud provider, all right, and that can be invoked over standard web protocols. They are platform independent, which means that they are independent of operating systems or platforms. They're also independent of languages and frameworks. They are discoverable. So a service can be discovered again over the internet, over the web, and in that context we also looked at what a registry is. So yeah, so it's discoverable using service registries and also using brokers that enable coordination between the various applications. So within the realm of web services, a client excuse me, a client on the other hand uses a service. So that when there is a service, there is a provider, there is a user. So the client is the consumer or the user of the service. So he requests something to be performed as advertised by the service. They get the desired result, or sometimes they also get an error if the parameters or the usage is wrong. And also what's important, again, I've said this so many times before, but I'll say it again. The users do not need to know how it's implemented. It is possible that web service and components could be proprietary and not open source, so it doesn't matter anyway, right? So you shouldn't, as a developer, you shouldn't concern yourself, you shouldn't be bothered about how these services are implemented. Okay. Here are some of the basic web services technologies. We have WSDL, which is Web Services Description Language. It is the standard used with web services. WSDL is based on XML. I mentioned this before. So XML is what we use in distributed environments. So using WSDL, it is possible to access web services, and it is also possible to define the interface for web services. It can be used with the UDDI, or Universal Description, Discovery and Integration, which is a worldwide registry. So we have mentioned the use of registries so many times before. So the UDDI registry implements the UDDI specification, which is a web-based distributed directory. So that's all it is. It's a directory service. So it's a repository, a directory service, right? So it allows for businesses to list themselves on the internet. Using UDDI, they can discover each other. It's something like we were looking up at a phone book. So you don't know the details of something, you look up the phone book, you get the details of the business, right? So that's what it is. So this registry holds very useful information about the business and the services offered, and it also contains very detailed documentation on the various services. The UDDI supports an interoperable platform which allows for businesses to find web services over the internet. That's what it's all about, guys. It's about finding the services. So all the information about the services are stored within a service registry. So you can see the diagram there. So we have the service registry which holds the service description, etc., etc. So yeah, if you look at the diagram, you can see the communication link between the service provider and the service registry. So there is with the UDDI and the SOAP communication messages being exchanged between the service registry and the service provider, the description. So that the service provider uses WSDL to describe a service. So what do you mean by describing a service? Describing something is defining what a service does, what input it takes, what output it produces. So obviously, if the cloud provider wants other businesses to use this service, they will need to publish this information somewhere, and that's what the service registry does. So what they do is they publish this information in the service registry using UDDI and SOAP, Um, so what a service consumer does is a service consumer, or which on the left hand side of the slide, they will exchange UDD and SOAP messages with the service registry. They will discover the list of services. They will discover list of services. They will pick a service or a set of services. They'll bind the service to their application and then they use it. Right? So I hope that's clear, chaps. So the flowchart makes it very easy to understand. So the first thing is a service has to be defined by service provider. Second step is service has to be registered. Once a service is registered, the service registry, the service consumer searches. He's going to search or query the service registry to look for a service. Once they find the services they need, they're going to bind the service to their application. Right? And the SOAP message is exchanged between the service consumer and the service provider. And that's pretty much is the entire process really. All right? Now there are many ways to work with web services, and there are many protocols that can be used. You do recognize some of the protocols like HTTP, Hypertext Transfer Protocol, FTP, File Transfer Protocol, etc., etc. You can look up at other protocols, or you might already have some experience in working with some of the other protocols you see on the slide. I will let you do some research on the various protocols. But what is important for now is, please note, please note that note the layers of the web services delivery. It's up to you whether you want to see it as a bottom-up approach or a top-down approach. But what you can see is the transport layer could use common protocols like the like HTTP, right? And then we have the data layer, which is dependent on XML, and then we have the service layer, which is SOAP and WSDL. And we of course have we also need to address things like WS security, reliability, policy, etc., etc. So that's like the it's not a framework, but it's more like a stacked approach to web services. Now we will discuss how web services are implemented. First of all, we need to understand what is the role of SOAP. Okay, what is a SOAP message? In simple terms, SOAP is a protocol. It's a protocol to exchange data between applications built using different programming languages. So that's what it's all about. It's about making sure that different languages, different applications built using different languages or platforms can communicate with each other. Of course, in a distributed environment, there will be different applications built using different type of programming languages. So how do we facilitate the communication between these applications? The answer to that is using SOAP, right? So how do you enable effective communication between these applications? So that's why we use SOAP. SOAP was created to define a means of simplifying access to objects in a distributed environment. So the goal is to be able to access services and objects irrespective. So the goal is to be able to access the services and objects irrespective of which platform they have been built on. Now this is made possible because SOAP uses XML, which you guys know is rather universal, and this is what brings simplicity to SOAP messages. That's all it is. So using XML. So SOAP messages are defined using XML. So as I said before, it's like pretty much standard, universal, I suppose. So different applications can understand the SOAP messages, right, which is implemented simply using XML. Well, if you look at the diagram again, you see the actual the flows, I suppose. Um, so you see a requester, right? It's a SOAP client, and they communicate with the service provider. This means that both the requester and the service provider must communicate using SOAP messages. So it's about compatibility. So when we say it's very simple way of being compatible, use SOAP messages. Simple as that. The web service provider provides the implementation of a service, as we know, and makes it available or exposes them using, when we say exposing, it means that it makes it available to the users using WSDL and SOAP. The services could be implemented on whichever platform they wish, for example, Java, .NET, etc., etc. And it should not matter. So the implementation details should not matter to the requester because the service provider can be accessed by a requester irrespective of the platform. If there is one message you can take from today's lecture is that, okay, everything is it's independent, right? It's not dependent on any platform. So a service developed on one platform can be made available to an application to be developed on a different platform. So all of that is possible, right? Yeah. So you can see that the SOAP server, as the name indicates, implements the SOAP protocol, and the HTTP server is a standard web server, right? The HTTP server is a standard web server because HTTP web uses HTTP. So to make it all very clear, let's look at this flow diagram. This slide makes it all very easy to understand, I hope. Yeah. Because it shows an exchange of messages between the client and the server. It shows the exchange of messages between the client and the server. In this case, when we say a web server, it means a service provider, right? So when we say web server, it's a service provider. So the first step, which you see there, is for the client to find the web service they need to use. And let me ask you right now, where do you think that information is stored? The first step is for the client to look for a web service. Now, where do you think that information is stored? Is stored in some repository, or what we mentioned about 2 slides ago, it's stored in the UDDI registry. It's all the same thing. Well, it's a similar concept. So it's like a database of information about various web services, right? So the client queries the UDDI registry. So basically the client sends a query to the UDDI registry, and the registry responds with a list of web services. The client then selects a web service and gets the web service information from the list of registered services. Obviously, this information is passed on to the client in the form of a URL. With that information, the client gets the service description from the web service, and they get sent a contract. Then the client sends a SOAP message to the web service, which could bind that service to an application being developed by the client. You have realized that the web service description language, or WSDL, creates a uniform communication medium between the client and various parts of the web services architecture. So if you just look at the diagram, it's pretty much self-explanatory. So we now look at the web services description, WSDL. Rather, how do you go about defining WSDL to enable the web services? So let's quickly look at how or look at the WSDL description. WSDL describes what a web service can do and provides the names of the available methods. What this means is that when a client wants to access a web service, they will know which methods are exposed by the web service. So again, going back to what I said about being exposed, exposing a service means making it available to external users. So using WSDL, the users will also know which input a web service takes and what parameters are needed and what output it produces. They will also know what web service returns, obviously. Well, like a function which you are used to already in programming. The web service requires parameters or arguments. So it needs to tell it needs to tell the user what data types it can handle. All right. So just as you use a function, you say int a or string whatever, right? It needs to handle specific data types, and this information must be made public by the web servers. Also, finally, WSDL can be used to describe how the service must be bound with an application and also any relevant ports that need to be used to use the service. As said before, WSDL is XML based because it supports, I suppose, some sort of a commonality, irrespective of the distinction between various systems and applications. So remember that there may be a lot of differences in the various types of applications, but WSDL should still be able to communicate because it's XML based. So right, chaps, this part might sound complicated, but don't worry about it. In the next slide, that's an example for you to kind of get an idea as to what all of this means. All right. But nevertheless, if you understand XML, you will understand this as well. You will not have any problems. So we are going to go through a few rules of specification, rules of engagement, I suppose. I'll be a bit more clearer. I think you will be a lot more clearer with how this works if you look at the next slide. But for now, let's just go through some of the ways to define the abstract part and the concrete part within WSDL. All right. So there are two parts, as you can see from the diagram. That's the abstract part and the concrete part within WSDL. So we need to know how to define messages under types. We also need to define the services and the operations within the components, within the services. In order for the operations to be executed the service needs a request message and a response that need to be sent. Okay. So now an operation is invoked based on a request message. And when the request message is received by the service, it then responds. All right. So the specification will start off by defining messages and their types. Let us say the web service offers an operation O1. It could be conditional. It could be conditional on request message M1 being sent and the response message M2 is returned. All right. So like I said, chaps, there is an example in the next screen which will give you some, well, that's a tiny exercise for you. So you can try and work through the different tags of the WSDL specification. All right. Yeah, but don't worry, you will pick it up pretty quickly. The client will also need to know how to bind the service. Like we have said before, when a service is found, it has to be bound by the client. So it will be the service needs to tell how this has to be bound. It also needs to tell how the service can be implemented, for example in SOAP. So for example, the specification can say that messages M1 and M2 need to be in the body of SOAP messages. So the SOAP messages enables our communication. So the messages should, like M1 and M2, need to be encapsulated within the body of SOAP messages. Finally, there is the URI, the Uniform Resource Identifier, which provides the information on how to access this service on the internet. So like I said, chaps, let's actually go to the next slide and see the example, and let's see if we can figure out the specifications we have just described. So yeah, I know it looks like a clutter, but that's an example. This is a small example actually. You can see the message name and type. You can see the two messages. Get quote response, the get quote response, and then we have get quote request. Observe the tags used. Observe the tags used. For example, this WSDL message right there, and the slash WSDL message. So that's where the messages are defined. So first message, second message. You can also see how the operation has been defined right there. And I said it could be conditional, right? So it could be conditional to an input message, get quote request, and there's the output message, get quote response. So these things are quite familiar now. So it corresponds to what we discussed in the previous slide. So what I would like you guys to do is please make some notes on the other tags you see here. Look at the other tags you see here, and just make notes on how they are defined. Now, for example, I mean the key things there are you able to spot? Are you able to spot where the port is defined, for example, and where is the uniform resource identifier? I would like you to make notes on these things, chaps, right? And also please tell us how, if a user were to bind this service, how would they actually go about doing that? How would they bind this service at their end? So please make some notes on that. All right. So we are nearly coming to the end of this lecture now. So we have the web services. So we have the UDDI, which is the registry. Well, it's related to the registry. So we'll just look into that quickly. So the UDDI is, as I told you, is a standard for describing, publishing, and finding the web services. It's still evolving. It's still evolving, and as said before, it uses XML-based description for services. Because we are talking about the registry that holds information about various services, it is organized into different pages, right? Those are technical terms. So it's organized into different pages. The main components are the white pages, which contain basic contact information about an organization. Then there is the yellow pages, which contains classification of organizations based on industrial categorization. And finally, we have the green pages, which is the technical side, I suppose, which talks about the services offered by the registered organizations. Now, the question for you guys is, how does a business access a UDDI registry? How does a business access a UDDI registry? You probably guessed it right. That's a UDDI API, which has to be used with SOAP messages over a web browser. So yeah, so there are a lot of companies that run global registries. There are a lot of companies which run global registry that contain the information of web services. Also, a number of companies run corporate business registries. There are two supported operations with UDDI. A business can register a web service or they can find a web service. Alright, so they can either register a web service or they can find a web service. And the registries can be accessed using API or a website interface. So right then, chaps, so that concludes this lecture. So thank you very much.